Hey, so hi, thank you. So I'm going to be basically just discussing a brief overview of my honours project this year that was on the Southern Hairy-Nosed Wombat in the Nullarbor. So the Southern Hairy-Nosed Wombat is South Australia's faunal emblem, and they are a nocturnal and semi-fossorial marsupial. And much like some of their relatives, they are probably most well known for their construction of extensive underground warren networks that they use for shelter and as a thermoregulatory strategy. Now, the Southern Hairy-Nosed Wombat currently resides in 5 main fragmented subpopulations across the state and extends a bit into Western Australia. And although they are relatively stable and abundant at the moment, historical range contractions in response to land use changes, grazing competition, as well as some long-term studies that have noted reduced fitness with prolonged exposure to drought, we want to have a better understanding of species-environment interactions, as well as how populations might be affected in the future and what that might look like. But unfortunately for us as researchers, the largest and most extensive subpopulation of the species resides in the Nullarbor Plain, which is a very remote region with a very distinct, harsh, open semi-arid climate that we have a very strong difficulty in deriving sufficient data for. So my project intended to use a data set that I've been helping to create over the past couple of years, where we've been using warrens as a presence proxy for both the wombat and its largest competitor, the European rabbit. Now, using their distinctive features of these warrens and the open visibility of surface ground in the Nullarbor, we've been able to sample all noticeable wombat warrens within randomized quadrats, where we've derived 33,364 wombat and 7,367 rabbit warren locations, covering approximately 120,000 square kilometers of this region. Now, first, we wanted to be able just to ensure that what we're observing in the satellite imagery is actually the warrens. So we used some field validation, and basically the main takeaway from what we were able to derive, as well as some other data, was that digitizing can account for pretty much all observed wombats, but rabbits were a bit harder to identify, and we had higher emission errors there. But overall, wombats, we were extremely confident in our capacity to digitize. Now, what can we do with this data? Presence data often that we want to use in spatial analysis is small in sample size and often demonstrates a range of spatial biases that violate a lot of basic model assumptions that need to be accounted for during data preparation when we use them for modeling. And so being able to use unbiased data sets that, in our case, describe species homes is really important for us to be able to understand where and why these individuals decide to live, forage, and breed. So just from the extracted data, we were able to note that of the 34 variables that we considered, rabbit warrens were distributed across a greater breadth of range for a lot of these, with wombats appearing to be more selective in their warren establishment. But the primary sort of objective was to look at using this data set for species distribution modeling, which allows us to look at sort of a multidimensional measure of relationship between occurrence data and environmental variables, and interpolate sort of a probability of species occurrence or habitat suitability. So we used Maxent presence only algorithm, where we were able to identify that with these interactions, there's a strong association with wombats with pH and mean temperature, while rabbits had a more strong association with rainfall and clay content. And from this, we've been able to derive an idea of how habitat suitability might change in the future according to a range of different climate scenarios. And so this is just sort of a brief visual sort of overview of everything, but at the top we have the current models, and the probability is probably, well, the most important thing that probably to take away is that regardless of what scenario that we used or model iteration or settings that we implemented, the general trend that we see is that for the wombats, there's a decrease in suitable habitat as temperatures increase, but comparatively rabbits seem to have an increase in suitable habitat, although this is a little less certain because of their interaction with rainfall, which we find harder to predict for. Now, models aren't sort of definitive, but it is informative for us as a basis of information that we haven't been able to obtain prior, and especially not at such level of detail. And by comparing these models between species and how they interact over time, we can begin to identify potential areas of future concern. And with the consistency of these trends, we want to have a better understanding of how climate change will impact the wombats regardless of how stable they might appear at the moment. So a lot of the data that we currently use is based on populations that receive a very different climate with much higher rainfall and lower temperatures. So being able to look at this area in detail for the largest population is really critical for identifying that future risk and being able to implement really targeted, effective research in an area that's really hard to access and derive sufficient data for. But yeah, so that was a very brief summary. If you have any questions, feel free to ask. Yeah, it's really exciting. So thank you for the funding. It takes a lot to get out there and it's quite a bit of a drive. So it helps to have a bit of extra funding. So thank you.